I'm excited to show you guys how to factor a polynomial by grouping the terms. So last video for this section, I showed you how to factor a polynomial by GCF. Now I'm going to show you how do you factor a polynomial by grouping the terms. So this is the second method we went over in class today. Just a reminder that this is for section 8-2 out of your whole textbooks. You may be able to factor a polynomial by grouping. So you can only factor a polynomial by grouping when a polynomial has 4 terms. That's a big piece of information, you guys. Let me use a different color on that one. It has to have 4 terms. If it does not have 4 terms, you cannot use grouping. It's almost like having a group of 3 and you can't have pairs. So you have to have 4 terms in order to make 2 pairs, okay? So it has to have 4 terms. You can make 2 groups and factor out the GCF from each group. So I went ahead and gave you this step here. Notice that this polynomial has something in common with this term here. What do they have in common? Look at them. They don't have the 5 in common, not the numbers, right? These are not in common, but what's in common is this binomial. They both have x plus 2. So what I'm going to do is I'm going to look at the big picture. So this is the big picture, and I'm going to take out what they have in common, and that's the x plus 2. I'll put a star on those so you know that they have those in common. So I'll take those out. And so now I have an x plus 2. And then what's left is going to be just 5, and I'll circle it, a 5 and a plus 3x. That's what's in common. So I found what's in common from the 2 terms and factored it out. This is the same idea that we need to use to factor a polynomial by grouping. So I have 2 examples for you guys to complete. That I'm going to complete for you and you can follow along with me. And here's our first example. We're going to factor the polynomial by grouping. So you really want to follow along, and of course I'm going to go over this in class with you in detail. So for this one, we're going to group together the first 2 terms, which is why it's called grouping, and then we're going to group together the last 2 terms. Once again, this is why it's called grouping, because you're going to group together the first 2 and the last 2. So that is always your first step, is to group. Next, you're going to have to identify the GCF from each pair of numbers. So let's look at the first group. And what is the GCF? Well, the GCF, and I like to write it out. The GCF, actually, let me go ahead and pause for a second. I would like to expand this so it's bigger. Okay, there we go. Perfect. Okay. The GCF of 6h to the 4 minus 4h to the 3rd. Remember, we always look at the number first. So the GCF of 6 and 4, the highest number that can go in the both evenly is 2. And the h that they have in common is h to the 3rd. And then for the second set of terms, the GCF here, for the second group, is you have to look at the numbers, right? So what number goes into 8 and 12 evenly? Well, the highest number that goes into both evenly is 4. And notice that the 8 does not have an h, so they have no variables in common. Now that I identified the GCF, now I'm going to go ahead and factor each pair using the GCF. So I'm going to divide this one by 2h to the 3rd. Divide this by 2h to the 3rd, and write that on the outside of my parentheses. And I'll go ahead and reduce, so this becomes 4, right? 6 divided by 2, excuse me, that's so silly. 6 divided by 2 is 3, not 4. 3. And then h to the 4th over h to the 3rd is just h. Minus 4 divided by 2 is 2. And then h to the 3rd over h to the 3rd is 1, and they go away. And that's my final part for the red part. Now I'll go ahead and do the second part. I'll divide them both by the GCF of 4, and then I write that on the outside of my parentheses here. And now I divide, so 12 divided by 4 is 3, and h divided by 1 is just h. And then 8 divided by 4 is going to be 2, and there's a minus, so it becomes minus 2. And now I want you to take a look at what I have. Notice that they have whatever's inside the parentheses is always what the 2 terms have in common. If what's inside the parentheses is not the same, that means you did it wrong. You factored by grouping incorrectly, and you need to find your mistake. So when you have the 2 same things inside the parentheses, you're going to take that out. So I'm going to take out 1, 3h minus 2. And then what's going to be left, it's what I'm going to circle right now, is these two terms on the outside. So inside my second parentheses is going to be 2h to the third plus 4. And now I have factored, and this is my final answer. Notice we went from this polynomial up here, and we factored it using grouping, and here's our final answer, and notice it's in two factored forms. Remember, I told you your answer will always look like this, or something similar to it. Let's try a second example. Okay, here's our second example, and I realized on that last example, it took us almost 3 minutes to do it. It takes a while, especially since I'm explaining every step, and because we're using a whole new method, okay? We're using grouping. So once again, we're going to factor the polynomial by grouping, and that means we group the first two terms, and we group the last two terms. Then I identify my GCF from the first two terms, so my GCF here is going to be 4. That's the highest number that can go into both numbers. And the variable they have in common is r. GCF for the second term. Notice that you look at the numbers. There's an invisible 1 here. 1 and 6, there's nothing in common except for 1. So I'll just put a 1. And then look at the variables. It has r squared and there's no r with the 6. So the GCF is just 1. And it's common. It's not common, but it's definitely possible to have your GCF be 1. So we got our GCFs. Now we're going to divide. So we'll divide the first by 4r and 4r. And we write it outside of our parentheses. And so now I get 4 and 4 divide out. That becomes 1. And then r to the third over r is r squared. And 24 divided by 4 is 6. So I'll put a plus 6. And the r's cancel out and reduce to 1. I kind of just crossed them out. There we go. And now we'll focus on the second part. If I divide both by 1, it's going to give me the same thing. But I just need to remember to write it on the outside of parentheses. And then I get r squared plus 6. Notice whatever's inside the parentheses is always going to be the same, right? These two are always the same. So I'm going to get r squared plus 6. And I just write it once. And then I circle what's left, and that goes on the outside, so I get 4r plus 1. And now I'm fully factored. I have my two factored form. They have nothing else in common. I can't factor it any further, and this is my final answer. Now, could be a tricky concept. If you see yourself having difficulty with factor the polynomial by grouping, then please make sure you rewind the video and practice the last two examples again. When you come to class, we'll practice as well. See you later.